Okay, I'm going to start the today's session. Okay, so in the previous class we have discussed about some of the questions which were related to the orthographic and isometric views. So in this class also we will see two different problems. One is an isometric view. We have to convert that one into orthographic views, and the next one is the orthographic views, and we have to convert that one into an isometric view. So we're going to see these two in the 3D as well, because I really want you guys to understand these concepts into the depth, because this is one of the easiest questions. If you guys see here, this particular question, if you can solve the orthographic views of this particular isometric view, then you will get 12 marks. Okay, of course from each unit you have to answer only one. Either if you became perfect at any one of these, like converting isometric views to orthographic or orthographic to isometric, it is really going to be helpful for you. Get good marks in the drawing. Drawing is a very easy subject in which you can score good marks. Okay, so without wasting time, I'm gonna first try to solve this problem. Okay, so we have to, let's see the problem here. Draw the front view, top view and side view of the block shown below. All dimensions are in mm. So we have to convert this isometric view into an orthographic view. Okay, so what do we need to do first? First we need to see the arrow. So the arrow direction is not here, it is here, which means we have to watch, we have to assume that, we have to imagine such a way that we are in front of the object here. Okay, not here. We are assuming that we are here and we are watching this object. So when we are watching this, what are the things that we actually see? We have to draw them. I'm gonna go to the AutoCAD. Z, enter. I'm just trying to zoom in as much as possible. So from the front view we will be able to see this L shape, this particular face and this particular face. Okay, and what else we are able to see? Nothing, these two faces. So the depth of this one is 40 and the width is 50 and the height is 10. And 40 again, 40. That's one face that we see, and this face also we will be able to see. This face dimensions are 20 and the height is 15. (15) 20. By the way, I told you guys to solve a problem, right, regarding these isometrics and orthographics. Good morning guys, good morning. But only I think I received only 1 or 2 mails. Okay, if I was to give the internal marks for you, you guys know that drawing internal marks is for 40 marks, right? If I was to give you guys good marks, I should have certain evidence. Without evidence, how can I give you good marks? So send it to me by today evening, or otherwise I'm gonna put it as 0. Okay, so here that's the front view. That is how we actually will be able to see this particular block here. And after that, if we were to take the projections, let me give this one a different color. Since this is a first angle projection, front view comes first. Sorry, top view will be below the front view. I'm going to trim these portions. Okay, now so from the top view, what are the things that we actually see? We will be able to see this face, and we will be able to see this face and this face as well, right? Since we are already got the width 50 here, this line dimension here is 50, so the height has to be 40. And we have to see here this particular edge here, and which is nothing but this one, and when you watch it from the top, these two are on the same straight line, right? So we can take a projection here from this one or from this particular line until they made this point, and after that we can take this line, we can take this projection, not at all the way, but whereas you can use this projection in order to determine the width of this one. It actually reduces some time here for you. And now we need to create this rectangular block of 20 by 15 here. Previously we've used 20 by 15. Now we need to create a face with 20 by this 15. That will, of course both are 15, but this 15 and that 15 both are different. So from this edge, at what dimension we have to start? See here, this total dimension here is 40. If you subtract 15, you will left with 25, right? So which means this one seems to be at the middle, this block. So 40 minus 15 means 25. So this particular dimension and this particular rest of the dimension, okay, this dimension and this dimension both are of dimension 25. So which means if you divide this one with 25 by 2, you will left with 12.5. Or otherwise you can also take the midpoint of this. Okay, you can also take the midpoint of this particular line, and you can connect this one to this particular midpoint. Okay, whichever the way is fine. So I'm gonna start from this location to 12.5, and from this location also with dimension 12.5. I'm going to trim these additional portions. Okay, so that is how it actually looks from the top view. For now I'm going to just delete these lines. Actually projection lines has to be there. Okay, there has to be projection lines, but because if you guys use the projection lines, you can solve the problem very much quickly. I just showed you, but whereas I just want to show you guys how does it actually the orthographic perfect view. So that's why I don't want you guys to get confused, so that's the reason why I've deleted them. I gave this one a color blue. Now we need to draw the side view. he just mentioned about the side view. So which view that you need to actually take? Left side view or right side view? Good morning, ma. Anyone? Which view we actually need to take? Yeah, Jayant, I've seen the mail. You know, tell me. Now I need to take the side view as well, right? Which view do I need to actually take? We are actually taking the left side view most of the times, right? But whereas here, if you take the left side view, that is also fine. But if you take the right side view, okay, like you're watching this object from this particular location or from this particular direction, then you guys will be able to see this face and this face. So try to take this one, try to avoid these hidden edges. If you try to watch this one from this side, that is also fine. He just mentioned about the side view, but whereas what is it he actually trying to say is draw the side view of this one, which is nothing but the right side view. When you watch it from the right side, how does it actually looks? So if it is a right side view, means it will come to the left. So I'm going to take the projections again. So from the right side view, we will be able to see this face, which is nothing but this line. So take a dimension of 40, that's fine. You can take it till the end. Something, yeah, right. Now we have mentioned this particular face. We need to mention this particular face right now, so which is nothing but 15 by 15, which will start in the middle, starting from 12.5 and again 15. Oh sorry, I think I might have used a dimension on 15. That is how it will look like, but this particular projections will not be here. Okay, they will end somewhere near to this location. I'm gonna need to delete this line first. And lastly, yeah, that's it. That is how it looks from this side. Okay, it should have a height of 10, and this one is having a dimension of 15 by 15, which is nothing but a square, and this one's height is 40. We have taken this one from the projection, so there is no problem. Now what I'm gonna do is I'm gonna try to create this one in 3D. Just want to show you guys how does it actually looks, and now why have I actually taken these views. I'm gonna give this one a different color. I hope some of you might be practicing at your homes, you know, this AutoCAD. Practice guys, because just by using right side, what is right side? Yeah, right side view. Just because, you know, having some good grip on this AutoCAD, so many people are working on this one. so many people got jobs. So that's why it's my sincere suggestion. And that too, ultimately, obviously, civil people, especially for civil people, if you want to go outside to get a job, if you have this one in your resume, professional certification, yeah, then obviously you'll have a better chance of getting a good job. You guys actually need good certifications. Okay, apart from that, let me this one. I'm gonna go to the 3D modeling. There are so many ways to do so. Either I can take this rectangle, I can just extrude that one, or press pull that one. Okay, now I need to give the dimensions. So the front one is a 40. Oh, sorry, wait. This one is 40 and this one is 50 to a height of 10. 40, 50, 10. Now I'll go to the shaded with edges mode. Now I'm going to create a rectangle, or otherwise I can take the it is not giving any specific ideas. I'm going to take this line. Ten. 40. I'm going to take the press pull, select this region. Since we have already allocated 10 mm of dimension, we have to extrude this one to a height of 30. So how do I actually make these two as one? We have an option which is nothing but union, solid union. Either you can use that. I think I might have already done that. Yeah, no need to, because I have taken this. Wait. Okay, now I need to create this block of dimension 20, 15 and 15 again. So from this particular line I have to move to a distance of 12.5. In this direction I have to move to a dimension of 20, 15, 20 again, 15. Now again I'm going to take the press pull to a height of 15. So that is the actual three-dimensional figure that was given to us. Okay, I'm going to take the viewports. Okay, first I'm going to show you the front view, top view and side view. Okay, so how does it actually looks from the front? Oh, sorry, we have to convey this one, right? We have to change the directions. Wait, I'm going to make this as unity. Yeah, they became one, no problem. Now I'm gonna take the 3D rotate command. This one, two. This one is not working. Since the orthogonal mode is turned on, I will be able to rotate this one. So from the front view, that is how it will look like, right? So isn't that what we have drawn here? Exactly the same, right? If you compare these two. So you guys should be able to imagine, what's the front view is going to be, how the front view actually going to look like, and how does side view actually going to look like. You guys should be in a position to, excuse me, okay. You guys should be in a position to imagine all of these and while drawing. Okay. Now, if I rotate this one like this, actually that's the right side view, right? Since we are drawing the orthographic views, ortho means straight, 90 in Greek. That's the side view. Observe this one. Both are similar, right? Okay, now the top view, we will see the top view. So that's the top view. Not able to rotate this one. Okay, so that's the top view. That is how it is going to look like from the top. So the reason that we are actually taking top view at the bottom, which is below the front view, I told you that reason. It's all because of this is the first angle projection. Is it really a first angle projection, since we have taken the side view onto the right? I'm going to give the dimensions. Now we can just define whatever the view that we want. I'm going to move this one a little bit higher. Guys, tell me whether it is the first angle projection or a third angle projection. Oh, I lost it. Okay, I'm gonna save this one for you. I'm gonna upload it in the Google Classroom 2620. It is here. I'm gonna save the solid as well. X20. I've saved both of these files, okay, for your reference. For the next class, actually, I just want to give you some assignment. Okay, everyone understand? Left side view. Yeah, there is. You can also take the left side view, no problem. I'll give you a different problem for the assignments. Okay. If it is a left side view, means you have to take one more thing here. I think you can just trim this. Okay, you have to take the projections again. By the way, I forgot to mention the projections has to be there. Never ever erase the projections. Keep the projections alive. Now take the projections. From the side view also the dimension is 40. Oh wait. Okay, so whatever these locations are there, so at those particular locations you have to take these are all hidden edges. Okay, I'm not taking the exact dimensions here. Okay. So that is how it will look like from the left side view. But whereas there all should be hidden edges. Okay. This one, this one, this one. They should be indicated with dotted lines. I'm going to create a layer for them. I'm going to change the LTS factor to 0.3. Okay, so that is how it will look from the left side view. Wait, I forgot to That's the place where it is going to end. That's why projections are very much important. They can, reduce the time. That's it. Oh my god. Guys, I lost the power. I'll be back in 10 minutes. Oh, this one. Okay. So see here, this is the figure that we need to convert. These two are the orthographic views. So since this particular view is actually above this view, you can actually say that this one is the front view. So this is how it has to look from the front, and this is how it actually look from the top. Since we are all talking about the first angle projection, we are assuming that the body is actually in the first quadrant. Okay. Wait, where is that? Yeah. So how do we actually convert them into the isometric view? Even if it is your drawing sheet, first draw a line. Right. I'm gonna zoom in as much as possible. Draw a horizontal line first. After that, so the perpendicular lines has to be marked at 30 degrees of inclination with respect to the horizontal plane. So what's the dimension of this line? 50, right? So draw this one at 30 degrees of inclination, 50 at 30 over. Now try to draw this particular edge here, which is this edge, so which is 80, same theory, 80 at 150. Okay, so we don't need this one right now, so we can delete that. So that's why draw this line with the H or 2H pencil, and after that it has to be given a height of 25. You can just leave this one vertically, no problem. So 80 at 30 and join these two directly. Now see here, what has to be done now? We have to draw this edge. This particular edge is parallel to this one, which is nothing but, keep this one here, and it has a dimension of 10. So draw 10 at 30 degrees of inclination. Now again repeat the same procedure, 80 at 150, join these two. Okay, similarly try to do the same thing on the other side as well. 10 at 150, 80 at 150, 10 at 30, and this one has to be defined with a certain angle. So here if it is 90 degrees of inclination means it is going to be 120 degrees of inclination. So draw this line at yeah, this angle is fine to this at 30. After that, here also there has to be an inclination of 60 degrees. What I'm going to do is wait. From this midpoint I'm going to draw a vertical line. I'm going to divide this one into 60 and 60 at 60 and 60. 60. So which means if it has to be 60 means the angle has to be 120, right? So then only, so I'm going to take a dimension of 90 at 120. I'm going to do the same on this side as well. Right, I think this is not going to, has to be 150. So let's take some 100 and some 150. Similarly, some 100 at 30. So for that, whatever the lines that you're about to draw has to be parallel to these lines. So connect them like this. Now you can just delete these lines. Angle seems to be 120. Now let's try to measure the angle. And take the angular dimension. Yeah, this one is now still seems to be 120. I think I might have done something wrong here. Angle has to be 120. No, I think it has to be 120, right? Let me draw some vertical lines here so that it is going to be very much clear. Okay, this one is not vertical, so I'm going to draw a vertical line here. This one side is not defined but the angle, so here it has to be 45. See here, if this one is 90 means this angle is 45 and this angle has to be 45. So what we are going to do is we are going to take the lines at 30 degrees of inclination. I'm going to try to take the lines with respect to this one. Yes, this one is 90. I need this one at 30 with, yeah, let's take 20. Now similarly from this location also let us try, yeah, 120 is fine. 30 at 120. Now let's try to measure the angle. Now that's correct. I'm going to trim these additional portions here. Since these edges are not there, I'm not going to show them. these lines now again has to be parallel to these. We need to measure the line dimensions again. I'm going to measure this line dimension. .98. We can actually take the same lines, but whereas 30 degrees of 120 degrees of inclination. So let's take some 24 at 120. At 30 degrees of inclination, they are going to get coincide. So I'm gonna just extend this line. That's it. So that is how it will actually going to look like, okay, for the 90 degrees of inclination. Oh wait, it has to look like 120, right? Okay, let us increase this angle. It will touch somewhere near to this one. I'm gonna slightly increase this inclination. So this inclination is 30. Right. This one is, if this is 90, if it has to be 120 means I have to take something line which is 30 degrees of inclination to this one. Since this one is at 150, I have to take 180 degrees of line. Now that is something, I have to take a horizontal line at 0. So I can now trim these additional portions here. I'm going to trim these. Now let's try to measure the angle between them. Yeah, it is now 120. Actually it seems to be 120, but it is not exactly 120. At 120, let's take 25 at 120, and now similarly we have to take a horizontal line here, say 35 at 0. Okay, I'm gonna try this. So that's the isometric view of these particular orthographic views. Okay, so since it is 1 o'clock, I'm gonna end this session. I'll see you guys in the next class. If you have any doubts regarding this today's class, you can post to me in the comment section, or please repeat the assignment question or you send us. Yeah, it is compulsory to mention the hidden edges. If you don't mention the hidden edges means, yeah, it is there will be deduction of marks. You have to mention the hidden edges if there are any. Sir, can you please repeat the assignment questions, or can you send us the assignment classroom? Okay, I'll send them. I'll post them in the Google Classroom by today evening, and so submit them to me by next Friday. Okay.